minus 4, and was it? No. Well, then let's try this again. You took out a negative 4, x minus 1, and x plus 3. Yes? Okay. So that's the new denominator. The numerator we didn't care about yesterday when we were trying to find the domain of these rational functions because all we really needed to know was where the denominator was 0. So now we actually care about the numerator. We need to go ahead and factor it. So I'm going to pull this down here and I need to factor. So I've got x cubed plus 5x squared plus 4x. I notice that all of these terms have a what? X that I should take out as a GCF. So if I factor out an x, where does it need to go? On the outside of what? Parentheses. Very nice. So x cubed becomes x squared, plus 5x squared becomes plus 5x, and then plus 4x becomes plus 4. Lovely. You see a trinomial? Your first thought is factor by magic numbers. So two numbers that multiply to give me 4 and add to give me 5. 4 and 1. So my factors are x plus 4 and x plus 1. Do you agree with our factoring? Remember that when you factor out a GCF, it still is part of that numerator or part of the denominator, if that's what you're factoring. So it still needs to be included out in the front. Don't lose it. Okay. So if I rewrite this, the numerator is x times x plus 4 times x plus 1, right? And the denominator is what we found yesterday, correct? So negative 4 times x minus 1 times x plus 3, which is great. We have factored. Where do holes occur from today's notes? Where do holes occur? When you have two common factors on top and bottom, numerator and denominator, that you can do what with? Right. Look at your factored version of number 1. That's right. You don't see any. There's no common factors in the numerator or the denominator. So what can you conclude? There's no holes. It asks you in the instructions to find the domain and to find the holes. If you can't cancel out any common factors in the numerator and the denominator, that means there are no holes. So that is what you write.